Hello, this is Team Nuclear Penguins, and we are taking part in the Umine challenge. We have implemented our own custom uranium mining system within Minecraft. I am Rehan, and my teammate is Tirchalvan, and we are from NIT Calicut, India. So, let's begin. Let's connect to a server, and there we go. This is our mining facility. So, this is how it looks like from the top. Right, so we have chosen this location because um, this contains uranium ores. So let's start off with the first thing, which is our open pit uranium mine. We chose an open pit configuration. We chose to model an open pit because we felt that it would be most easy and it's also the most common and traditional way of uranium mining. In our case, we have open pit with autonomous trucks that can haul uranium back up the line. It has sensors which can detect um, the road and move along the road. We have our JCBs and our excavators which can dig up uranium. This is uranium. So that's what we're digging, and then we continue on to our next step in the mining facility, which is the our ore processing facility. So first we start off by processing our uranium ore by sorting it. So we want the highest quality uranium ore. So we have a facility here that gets the uranium. It's different ores, right? So we want the ore with the most radioactive nature because that means high uranium. So our mechanical arms automate and sort the uranium that has the highest radioactivity. So here we see that we have a monitor, a gamma ray monitor, and belt B has higher radiation, so that goes to crushing, while belt A, the less radiation, goes to the heap leach sorting. We have computers that connect to a SCADA system. Let's continue. Oh, we have, okay, let's continue. So this is our road where we have street lights for easy convenience. And next, we can see that the ores are being pumped into our crushing facility. So this is our crushing facility. And here we have our sag mill. So that's the sag mill. And here we have our secondary jaw crushers, which mixes water to form slurry, and we get a slurry. There's water being pumped here. Um, that's a power system connected. So then we continue on. This is actually our tailing storage facility, but we'll come back to this later. So now we go from our crushing facility to our chemical plant. This is where most of the magic happens. So first things first, we receive the slurry from here, and then we go and add it to our in the industrial pressure autoclave. So here we have a temperature gauge, and in chemical distillation chamber, we see that we are converting dry uranium, dirty uranium slurry, and we are adding H2SO4, and with that we are getting our um, leached slurry. We added catalyst here, which is the MnO2 catalyst, and we have H2SO4 for leaching. So yes, that's a pumps, and then we move on to the next step, which is countercurrent decantation. So in this step, we move the leached slurry through a bunch of 3 to 4, sometimes more than that, decantation containers, beakers, and we let it sit, uh, and then we take the underflow tailings and we send that to the tailing storage facility, and the overflow tailings are sent to the next step. And here in this case, we send it to the ion exchanger, where again we can like monitor the voltage specifically. So one second. So we can put on engineering goggles and we can see the voltage that's being monitored and so on and so forth. And so it's about 29 volts, and we say that the ion exchange is successful. And then we move on to the next step, where the elevate, as it's now called, actually, let me move on to the next step, which is um, Yeah, so we move it on to the filters where the resin extracts the eluate and we get the eluate, which is then sent to the heated tanks. Here, the eluate reacts with ammonia, and then we get our next step where we again put in filters, industrial filters, uh, and we stick in the tanks, and then we get our finally yellow cake. Well, you're starting to get yellow cake. So we move on to the next step here, where sorry, that's just embarrassing. Okay, that's embarrassing. Okay, let me just okay, okay, and so we move on to the next step, where yes, so we receive the yellow cake, and then we again monitor it for radiation and other activities, and then we send it to the other filters. So this is the push plate filters where you press and compress yellow cake to get maximum yellow cake, and then this is our other filter, and from there we finally um, we can see that in our machine here we finally enrich in the table, we finally get yellow cake element. So that's a success. Let's talk about our other things. So here we have our tailing storage facility. I'm sorry. So here we have our tailing storage facility where we get the waste tailings from there to our tailing storage, and we process it here in our waste treatment plant, not tailing treatment plant. And here we have our main control center where we implement SCADA, supervisory control and automation. And we notice that ALARA is in effect, meaning we are enforcing as low as radiation possible for everyone. And we see that we are noticing about very little radiation, and it's in nanosiemens units. That's a SCADA unit where we can monitor everything. A yellow cake production, about 1 ton yield was yesterday, and that's a power generation, solar and wind, 10 megawatts and 25 megawatts, which is sustainable because we, as you've seen, um, we actually have solar panels lined up on our buildings. So we can see that we're generating energy, and we can also see that we have a whole bunch of other solar panels lined up over here. So yes, that's it. Thank you.